Now we're going to look at volumes of solids of revolution. This happens when we take a two-dimensional figure and rotate it. So if I rotated that figure, I'd get this vase-looking figure over here. Now, if I sliced it, I would get a whole bunch of circles, right? Every single one of these is a circle. Pi r squared. Pi r squared. And the width of them be dx. And you add them all up, and you have the figure. So that'd be pi, and the radius would be from here to here, which is the axis of rotation. So here minus here, squared, pi r squared, dx. Now, if we shifted the figure up, we have kind of a hole in the middle. So we'd have to take the volume of the outer function minus the volume of the inner function. We'll get into that in examples. So, I think it's easier to see when you actually see some examples. All right, so we have this figure. And the first one says we're going to rotate it around the x-axis. So we have y equals x squared, and then y equals x plus 2 here, going from -1 to 2 along the x-axis. So if I did the revolution, we end up with this kind of an interesting figure. This one would be kind of wider as it went around. It really looked like a vase of sorts. So since it's revolving around the x-axis, we don't have to worry about subtracting the axis of rotation. I tend to like to just keep it simple. So pi, the integral from -1 to 2, the outer radius, which would be the height going from here to that line, which is x plus 2, squared, the larger radius squared, minus the inner radius. And the inner radius is going to be x squared. Squared. So I like to think of it as you've got the integral of the big radius squared minus the little radius squared dx. That simplifies things. Now, we could do this with a calculator, but I want to kind of review doing this by hand as well. We need to clean things up a little bit. Now remember, x plus 2 squared means I'm taking x plus 2 times x plus 2. That's going to be x squared plus 4x plus 4 minus x squared squared, which is x to the 4th. And all of that has these little bitty dx's. So I could take the antiderivative. This would be x cubed over 3 plus 4x squared divided by 2 plus 4x minus x to the 5th divided by 5, all evaluated from -1 to 2. Yes, I know we can put this in the calculator, but let's just have fun. Pi. So let's see. Okay, if I plug in 2, I'd get 8 over 3 plus 2 squared. That's going to give me another 8 plus 8 minus 32 over 5. when I plug in -1, -1 cubed is -1. This would be 2. This would be a -4. Let's see, -1 to the 5th is going to be -1, but that's a minus. It turns into plus 1/5. Okay, so clean that up. Oh, I know y'all love all these fractions. Let's do all the ones to the, so we have 8/3 minus a -1/3, that's 9/3. 8 plus 8 is 16. And this would be a -2, so 16 minus a -2 is going to be 18. -32/5 minus 1/5 is -33/5. So that's a 3. That's 21. So 3 plus 18 is 21 minus 33/5. If I make that into a fraction over 5, that would be 105 over 5 minus 33 over 5. 105 minus 33 is going to be 72/5 pi. Now, if I was doing it in the calculator, I would do the entire inside and leave the pi out, because you want to leave them exact. Now, what happens if we rotate it around the line y equals 4? Y equals 4. That's up here. Oh, so now when I rotate it, I have this figure that's going up like this. It's hard to picture, I know. But I'm going to have something like this. And then it's rotated. It's kind of interesting. So for this one, the outer radius is actually x squared minus 4. Oh, I forgot the v equals. So the outer radius is x squared minus 4. I know technically it's 4 minus x squared, but when I square it, it's going to come out okay. Minus that's the line x plus 2 minus 4 squared, and all that dx. So x plus 2 minus 4 is actually x minus 2, and I have to square that. So pi, oh, we forgot to put our boundaries, -1 to 2 still. -1 to 2. When I square this, I'll get x to the 4th minus 8x squared plus 16 minus x minus 2 squared, which is x squared minus 4x plus 4 dx. Oh, I need to clean that up a little bit before I take the integral. So clean it up. That's going to be x to the 4th. Negative 8x squared minus x squared is negative 9x squared. I'd have plus 4x, excuse you. 16 minus 4 is 12 dx. This one's going to be easy to take the integral of. So what I want you to do is try it. And I'm going to go ahead and work it out on my end, and let's see if you get the same answer. So here's the rest of the problem worked out by hand. Hopefully you got the same answer. If you didn't, pause the video, go back, see where your mistake is. On the next one, it's about line y equals -2. So taking the same figure, but this time, instead of rotating it up around y equals 4, or just around the x-axis, we're rotating it around -2. So there's going to be a big gap in the middle. So for this one, my outer radius is going to be here, and the inner radius is going to be here. So the outer radius, sometimes this helps, is the x plus 2 minus a -2 which would be plus 2. And the inner radius is going to be x squared minus a -2. So the volume would be pi from -1 to 2 of the outer radius, which turns into x plus 4, minus the inner radius. So this turns into x squared plus 8x plus 16 minus x to the 4th plus 4x squared plus 4. Clean it up a little bit. And we get -x to the 4th plus 5x squared plus 8x plus 12 dx. Remember, you can always pause here and see if you get the same integral. Which I highly suggest. Don't just sit here and copy from the video. Pause it, try it, see if you get the same answer. So that's 8 times . So I think I messed up somewhere. Yeah, that's a 4. I don't know how I turned it into a... Oh, it isn't a 4. That's x squared minus 4. Oh, that was a -3. See, sometimes you don't want to even copy what I have. So that turns into minus x cubed. So minus 8 be 16 plus 24 minus, plug in the -1, plus 39. Let's see, 39 times 5 is 195. See, even mathematicians have to go on the side and do some basic multiplication. That's 162/5 pi. So what if we change the axis of rotation to the y-axis? That means we're going to be cutting along the y-axis. That changes things a little bit, right? I mean, we still get these neat little figures, and I wish I had my erasable pens. Does this one work? Oh, I don't have the eraser. So this one would look something like you'd have this circle at the top, a circle at the bottom, and it's going to kind of go in. Looks like a little hourglass. But if we're rotating around the y-axis, we're going to change our integrand. So this would be, so we need to change these to be in terms of x. So x equals, this would be x equals y squared, and this would be x equals y plus 2. Because we want everything in terms of y now. So we're going around the y-axis. We're going to be cutting this way. So these are all little dy's now. Same principle though. So I need to find the lower bound for the y's, -1. Upper bound is 2. And the outer radius, if I'm going around the y-axis, is going to be the line y plus 2. Minus the inner, which is going to be the curve y squared. Clean it up a little bit. That's y squared plus 4y plus 4 minus y to the 4th dy. That's y cubed over 3 plus 2y squared plus 4y minus y to the 5th over 5, evaluated from 2 to -1. Now, just to kind of show you what you can do, we'll do some of this in the calculator. Now, I could do the integral and do it in the calculator with x, with respect to x, but if we wanted to actually evaluate this, you could do 2 cubed divided by 3 plus, that'd be 8 plus 8 minus 32 divided by 5 minus -1 divided by 3 plus 2 minus 4. That would turn into plus 1/5. And we could use the math feature to turn that back into a fraction, 72/5. What if we revolved it around x equals 4? X equals 4 is a vertical line. Ooh, so we get this weird little figure going. It's going to be a kind of a funnel in the middle and curved on the outside like a big bowl. So if we're going around there, the outer, so big R, would be the curve minus the axis of rotation. And the little one would be this line minus the axis of rotation. And I'm going to start speeding this up a little bit. Integral from -1 to 2. Oops, I forgot squared. In the calculator, you have to stick with the x's. Change that to a fraction so it looks like we did all the work. And I get 108 over 5 pi. If we change it to x equals 7, here would be 7. Oh, now we got a big gaping hole. Still easy to do. Outer radius would be the curve minus 7. This would be y plus 2 minus 7. Same idea. integral from -1 to 2, outer radius squared minus inner radius squared dy. Try it yourself, and you should get 243/5